Hello everyone, I'm Tobia De Koninck and I will talk about ShinyProxy, which is a tool to easily deploy your Shiny apps. So I work for Open Analytics and we are a data science consulting company based in Antwerp in Belgium. On this picture you can see the Cathedral of Antwerp. So what is ShinyProxy? It's a tool to deploy data science apps in an enterprise context. This can be Shiny or Dash, Streamlit apps and so on. But ShinyProxy also supports IDEs like Jupyter Notebooks or Studio and so on. And of course also reporting tools like Quarto, Voila or R Markdown are supported. ShinyProxy supports standard authentication and authorization technologies such as OpenID. It also supports high availability and scaling, and it's 100% open source. So you can view the code on GitHub or browse all documentation on shinyproxy.io. On the bottom of the slide you can see some of the logos of the tools I mentioned. So here you see a screenshot of ShinyProxy. It's showing the main page of ShinyProxy with all apps listed in a grid. You can click on any tile to start the application, which we'll demonstrate later. So some use cases of ShinyProxy, and these are real-world deployments we have done. So starting with a simple deployment where there's just a single server running Docker, where there's one app and a few users. But there are also a public instance, which is using a Kubernetes cluster with more than 200 applications, where 300 unique users uses the applications day to day. As I mentioned, ShinyProxy also supports our Studio or other IDEs, and we actually have a customer where they support 200 users where they do their day work in our Studio on ShinyProxy. We also have a deployment where an app is embedded in a public website that's being used by thousands of concurrent users. And we also do some deployments in a validated or a GXP environment where full reproducibility and audit logging is very important. So the conclusion here is that ShinyProxy grows with you, both in the terms of complexity and in the number of users. So ShinyProxy makes use of containers, and those containers are Docker containers, and Docker makes it easy to create, deploy and run your applications. It allows to combine an application with everything it needs, such as libraries, dependencies and configuration, into a container image. And to write that container image, you need to write a Docker file, which is a set of instructions telling how to create a Docker image. For example, it contains which R version you need, which R packages, and so on. So why do we use Docker in ShinyProxy? It has many advantages. For example, application is bundled and installed into a Docker image, and every time a user runs an application, a new container is spun up and serves the application. So this gives a fully isolated workspace per user or per session, and it allows you to use a different R, Shiny or Bioconductor, or even any library for each application and combine it on a single server without installing this upfront on the server. So you only install it in a Docker image. You don't have to manage this on the server itself. Docker also gives full control on memory and CPU usage. You can archive every version of your application, for example, to achieve reproducibility, but also just to simply refer to an older version in case you introduced a bug. ShinyProxy supports Docker, but it also supports Docker Swarm, Kubernetes, and AWS ECS to run the containers. And it might be good to know that we can add additional backends if someone needs that. So let's have a look at an example application. We have written our R code into an app.r file, but of course you can also package it into an R package, which we actually prefer. Next up, you have to write a Docker file, and here I have created a very simple Docker file that starts from a very good R image from the Rocker project. Then the second line installs some system dependencies. Then we install a Shiny R package together with some library we need. And then an important part is to copy the R code into the Docker image. And finally, the last line tells Docker how to start our application. So with this Docker file, we have explained to Docker how to create an image. Next step is to create some configuration file for ShinyProxy, and this is done using the application.yml file. So it's a YAML file. The first few lines of the file configure authentication. So in this case, we use simple authentication, where we just define a list of users with their password. But of course, typically you want to reuse your existing authentication, which is fully supported by ShinyProxy. And then the last part of the file defines a list of applications. In this case, we have the Euler app, and we define an ID, a display name, and a description. And also we refer to the container image to use. So as you notice, the configuration is very simple, but we can make it a little bit more complex by introducing the seats per container setting and the minimum seats available setting. The first setting ensures that each container can be used by five users at the same time. And so the container is shared by those 5 users, and this allows for more efficient use of compute resources. So the CPU and the RAM resources are shared by the user. And the second setting allows ShinyProxy, or actually tells ShinyProxy to always have 10 seats ready for new users. And this ensures that the app loads instantly. Of course, in many environments, you still want a dedicated container per user. For example, if you need to execute a big model, or if you need security because of security constraints. So now that we have the Docker file and the configuration, we can actually start up ShinyProxy. And to do this, you simply download the jar file and execute it. Of course, there are more advanced deployment scenarios, for example, running ShinyProxy on Kubernetes itself. This is all supported by ShinyProxy. Just have a look on our website. So here's a quick demo. Basically, we start with the main page, and a user can click on a tile, and the application is instantly loaded. And we'll see that we can use it just as a regular Shiny application. So this is the basics of ShinyProxy, and let's have a look at what was new in the release we recently did. So one major feature is that we introduced the Shiny operator for Docker. So we already had support for Kubernetes, for a Kubernetes operator, and now we added support for Docker to that operator. And this operator makes it easy to create a production-grade and future-proof ShinyProxy server. So this operator will start and update your ShinyProxy server. It can handle configuration changes without downtime of ShinyProxy. It automatically setups and configures HTTPS, and it deploys the complete monitoring stack. So you have logs and performance and usage statistics. Also, it can handle multiple ShinyProxy servers, all on a single physical machine or a virtual machine. And it also can easily copy and configure your templates. Besides that operator, we also have made numerous smaller and bigger improvements to ShinyProxy. And we did everything to make using ShinyProxy even easier. So for example, we have improved the error messages and the logs. The ShinyProxy now gives faster feedback when a container fails to start, so that you don't have to wait for the container to time out, but get feedback immediately. We made it much easier to debug when a container fails to start or when a container crashes by extracting the error message from Docker or Kubernetes. The configuration is more forgiving in some options, so that you don't have to, just that it parses it a little bit better. During major upgrades of ShinyProxy or the framework it uses, there are no longer any interruptions. We improved mobile support. We also added an option to show apps in a grid instead of a simple list. We added Podman support, and as always, we improved the documentation, and we also added a lot of pages with more background information and more troubleshooting information. So I already mentioned that we improved the monitoring stack. We did this by integrating Graphana directly into ShinyProxy. So we always have used Graphana as an interface for the monitoring stack, but now it's embedded in ShinyProxy. It reuses the authentication system that's used by ShinyProxy, so you no longer have to configure it separately, and you also don't need a dedicated subdomain. So here in the demo, you simply log into ShinyProxy, and then you can scroll down and open the Graphana app, or just go to /Graphana. It will load Graphana, and you can select one of the dashboards that are made available. And here in the ShinyProxy usage dashboard, we can actually see, for example, the startup time of applications, the number of active applications, the number of active users, and so on. And the dashboard would also show when there are authentication failures or when an application fails to start. So this was a talk. Thank you for watching the talk. All documentation is available on shinyproxy.io. Feedback or feature requests or bug reports are very welcome. We also offer support, and feel free to reach out with any feedback. Thank you.